Imagine deploying your Next.js app to AWS EC2 in production without manually managing SSH keys, and instead using a GitLab CI pipeline to automate it all with secure IAM roles and AWS SSM Agent. So the moment you do a git push, the next minute your app is updated on production. In this video, I'll walk you through building a GitLab CI pipeline to deploy your Next.js app to AWS EC2 in production with just a git commit. What we are going to cover in this video: first, we will set up an EC2 instance on AWS dashboard. Then we will install Docker. Since we will be pushing a Dockerized Next.js app, we need to install Docker on AWS EC2. We will not use manual login through SSH to AWS EC2 instance, but instead we will use SSM Agent. So we will also install SSM Agent on AWS EC2. Then next we will create some required roles for GitLab CI and SSM Agent to get secure access to the EC2 instance. Once we are done with the AWS configurations, we will set up a GitLab CI. Then inside that CI, we will trigger the deployment script, which we are going to build at the end. So let's jump into the AWS dashboard and set up an EC2 instance quickly. Here I am in the AWS dashboard and I'll go to EC2. Next, I'll go to instances. At this moment, I do not have any instances, so I'll click on launch instances. Then I'll give this instance a name, so I'll call it Next.js app. I'll select the Ubuntu operating system, and for the image, I'm selecting the 24 LTS version, and this is also a free tier eligible. From the instance type, I am selecting t2.micro, which is also a free tier eligible. And next, I need a key pair. So we can use that key pair when we want to log into the EC2 instance for installing the Docker and SSM Agent. I'll select create new key pair. Next, I'll give this key pair a name. So I'll call it Next.js app, and I'll keep everything as it is default. I'll click on create key pair. Make sure that the key is downloaded to your local machine. Now I'll move to the network settings. So from here, I'll set it to create a security group for itself. Then I'll allow SSH traffic from anywhere for now. This is not the safest way, but you can set it to a custom IP or your own IP. But for now, I'll set it to anywhere. I'll also allow HTTP traffic from the internet, since we need to access this application inside a browser through internet. For the storage, I'll set it to 20 GB, which should be enough for the Docker and the Next.js application. Next, I'll click on the advanced details and I'll leave everything here as default. Click on the launch instance. The instance is created, and now if I go to the EC2 instances, then I go back to the instances, I should have an EC2 instance running here, and we are good to log into this EC2 machine from our local machine and install Docker and SSM Agent. To SSH into this EC2 instance, I'll select this instance here and then I'll click on connect, and here you can see the SSH client details. You can click on the SSH client. First thing it's suggesting is that open an SSH client and then locate your private key, which we downloaded when we were launching the EC2 instance. Then I'll copy this command chmod 400. I'll run this command on my downloaded nextjs.pim key. So I'll copy this command and I'll switch to the terminal, and here I have my .pim key. So I'll run that command here, chmod 400 nextjs-app.pim, and this should change the permissions of this file. And next it says that connect to your instance using its public DNS. This is the public DNS for the EC2 instance. To SSH into this instance using your private key, you can copy this example command from here. Switch back to the terminal and paste your copied command here, SSH, and then with the -i it will pick this file .pim, and then it will use the user Ubuntu with the public DNS of your EC2 instance. So now if I hit the enter button, it should SSH me into the EC2 instance. So I'll select yes here. Now I'm logged in into my EC2 instance. So I'll quickly run a few commands to install the Docker engine and the Docker CLI and everything we need for a Docker setup. First, I'll run the apt-get update command. Then I'll install these two packages, CA certificates and the curl. Now I'll add the Docker repository to the Ubuntu repositories here and I'll run it. I'll update the local repository here. And then I'll run the final command to install Docker Community Edition, CLI, and everything related to the Docker setup. Now the Docker is installed, and after you install the Docker engine, it is recommended to run your containers without sudo. So I'll create a Docker user and then I'll add that Docker user to the Docker group. So this Docker group already exists. Next I'll add the current user to this group, and to make sure this user is reflected in the Docker group, I'll run this command new grep docker. To confirm the Docker is working properly, I'll run a dummy container called hello world. So here you can see the message hello from Docker, and this means that the Docker has successfully pulled the image hello world, and then it has run the container, and the container has printed this message hello from Docker. The next thing we need to do is the SSM agent. So I'll run the command sudo snap install Amazon SSM agent. The SSM agent is already installed, but we can just confirm that if it's running or not. I'll run this command sudo systemctl status of the Amazon SSM agent from the snap repository. Here you can see that the SSM agent is active and running. Now we are good with the setup of the EC2 instance by installing the Docker engine, Docker CLI, and we have also seen that the SSM agent is also up and running. The next thing is to configure a few IAM roles which we will be attaching to the EC2 instance and also to the GitLab CI. We can get access to the EC2 instance from the GitLab CI without manually managing SSH keys. Now let's move back to the AWS console and set up some AWS IAM roles. On the AWS dashboard, I'll click on the IAM. And the first thing we need to add is the identity provider, since GitLab is actually an external entity or an external service where we need to give access to GitLab CI to the AWS service, which is a completely separate entity. And if you want to give access to some external services to the AWS services, then you need to configure the identity provider. First, you update the AWS IAM that, okay, this is the identity which I am going to add here. And if a request is coming from this identity, then you need to check these ABC permissions and act accordingly. First, I'll go to the identity providers. You can see the message here. Use an identity provider to manage your user identities outside of AWS. Since GitLab is outside of the AWS, an external entity, we need to use identity provider to assign access to some specific entities inside the AWS. So I'll click on the add provider, and then I'll click on OpenID Connect. Establish trust between your AWS account and identity provider services such as Google or Salesforce, or you can say GitLab or GitHub. So I'll click on OpenID Connect, and then I'll give the provider URL here, who is actually the provider of that identity. So the provider of that identity is gitlab.com. Then I need the audience, so the audience is also the same as the provider URL, and then I click on add provider. So the identity provider is added. Now I need to assign a role or a set of permissions to this identity provider. So when I'm using this identity provider inside a GitLab CI, the AWS knows that, okay, this was the identity this person added inside the IAM identity providers, and this identity provider has access to this specific permissions which are specified by using the IAM role. Now I'll go back to the IAM roles. I'll click on create role, then I'll click on web identity, allow users federated by the specified external web identity provider. This is exactly matching with the identity provider. I'll click on the web identity, and here I can select identity provider which I have created inside the IAM right before this. Here you can see login with Amazon, Cognito, Facebook, Google. We have created this custom identity provider, gitlab.com. So I'll select that. If you have multiple audiences, like based on the branch name or the commit name, you will see a list of audiences here. Since we are giving a global access to the gitlab.com provider here, I'll select just gitlab.com. Then I'll click on next. Then I'll assign a set of permission policies to this role. Since we are going to deploy Next.js application to EC2, the first thing we need to assign is the EC2 permissions to this role. Here I'll type EC2 full access, and if you need to assign some granular level access to your GitLab CI in production, then you are recommended to maybe create a separate policy based on a JSON, or you can select a customized permissions from here and update it. And as you know that since we are not managing SSH keys manually, but instead GitLab CI will be getting access to EC2 instance through the SSM agent, we also need to assign SSM full agent access to this role as well. So I'll click on next, and I'll give this role a name, so I'll call it GitLab, and then I'll give it a quick description, and I'll click on create role. Now this role GitLab is created with the identity provider set to the GitLab identity. Now we need one other role where we need to give access to SSM agent to EC2 instance, so the SSM agent can SSH into the EC2 instance and they can deploy the containers there. So I'll click on create role, and here we need to give access to a specific service. So I'll select AWS service, and here I'll select the EC2 service. Then I'll click on next, and the policy we need here is SSM managed instance core. You can select this permission policies and then click on next. Then we need to give this role a name, so I'll call it GitLab SSM. Then I'll click on create role. And now we have two roles. One is GitLab, which is actually needed by the GitLab CI to get access to EC2 and create the temporary secure token. It also needs to interact with the SSM agent. And then we need another separate role called the GitLab SSM Agent, which is needed by the SSM agent to get access to the EC2 for running and stopping the Docker containers. As I mentioned that SSM agent need access to EC2, so we need to attach this role to EC2 as well. So when a request is coming from the SSM agent to the EC2 instance, the EC2 instance knows that okay, I have this setup permission policies and I should give access to this resource, which is the SSM agent, based on this setup policies. So I'll go back to the EC2 dashboard. Then I'll go to the instances. I'll select the instance here and then I'll click on the actions. Then I'll go to security, modify IAM role, and you can see here that we do not have any role assigned to this EC2 instance. If I click on this IAM role, so I'll select this SSM agent and then I'll click on update IAM role. Once you have this role assigned to the EC2 instance, this should be reflected immediately. But in case this does not work, you need to switch back to the EC2 instance where you are logged into the EC2 instance through SSH, and here you just need to restart the SSM agent so everything can be reflected in the SSM agent as well. I'll paste this command here, sudo systemctl restart Amazon SSM agent. Once this SSM agent is restarted, the SSM agent should be good to communicate with the EC2 instance. To revise quickly what we have covered so far, we are almost there. So we covered setup an EC2 instance, we installed Docker and SSM agent on the EC2 instance, we created the IAM roles for GitLab CI and SSM agent. Now everything is configured on the AWS side. Next, what we are going to do is we need to create a GitLab CI, and once we have the GitLab CI, we will create the deployment script which will be triggered by the GitLab CI to deploy our Next.js application to EC2 instance by using the SSM agent and the GitLab CI roles. To create the GitLab pipeline, I have this sample Next.js application inside this GitLab repositories. Under the gitlab.com, I have this repository called Next.js app, and inside this Next.js app I have this dockerfile.prod which we are going to use to build the Docker image inside the GitLab CI, and then we will push that Docker image to the container registry. From the container registry we will deploy it to the EC2 instance. If you guys have not watched my previous video on how to Dockerize your Next.js application for development and also for production, I recommend to watch that video first to know how we Dockerize our Next.js application for both local using Docker Compose and Dockerfile, and also for the production. Here inside this app directory I have the actual source code of the Next.js application. Now since we have this project already set up and the Docker file is ready, I'll go to the build step and then I'll go to the pipeline editor. I'll click on configure pipeline. I'll select all these existing stuff and I'll remove it. Next I'll paste my CI/CD script here. First I'm adding a build stage where I'm using a Docker image and using the Docker dent service. Here what I am doing is that I am just logging into the container registry, then I am building the Docker image from the dockerfile.prod, and the dockerfile.prod actually contains all the source code for the Next.js application, which is also the minified version. And then I'm pushing that Docker image to the container registry. This is all about the build stage. Then we have the deploy stage where I have set this stage to deploy. I'm using this AWS base image from the gitlab.com to communicate with the AWS, and it has a built-in AWS CLI as well. Here I'm using the token called ID tokens and then GitLab OIDC token, and I'm setting the audience to https://gitlab.com, which should be matching with the IAM identity provider where we created an identity provider for the gitlab.com, and we set the audience to gitlab.com as well. Next I am setting some variables by using AWS default region to US East 1, and here I'm setting the role AR into this. So I'll go back to the AWS console and I'll go to the IAM and I'll click on roles. Then I'll go to the GitLab role and I'll copy this ARN here. I'll go back to the GitLab CI file and I'll replace this role ARN with whatever role we have created for the GitLab identity provider. Then I'm running some script for installing the session manager plugin. This session manager plugin is required by the AWS SSM Agent to communicate with the EC2 instance using the SSM Agent. Here I'm downloading first, then I'm installing. After that I am creating this directory called AWS and I'm putting this GitLab IDC token from here into this temporary file called web identity token. And once we have an identity token, I'm pushing that identity token to AWS config. Whenever I run a AWS CLI command, AWS CLI will be looking into this AWS config for any token or secret key and AWS access key. Since we are not using any access key or secret key from any variables here, that's the reason we are generating this web identity token dynamically by using this ID token and then GitLab IDC token, which will be creating a secret token based on the GitLab identity provider. Once we have everything ready, including the session manager, the AWS session token, we are good to use the AWS CLI. First I'm printing the config here just to see what we have in the config. Then we are calling AWS STS get $identity token, so this way we can see what user or what resource is actually sending this request. Next I have this deploy to EC2 script which I am going to create right now. Once we have this deploy to EC2.sh script, I'll trigger that deploy to EC2.sh, and that deploy to EC2.sh will actually take care of stopping the existing container on the EC2 instance and then running the new container on the EC2 instance from this newly pushed Docker image here. Let's commit this. Let's go back to the code and click on the plus button, add new file, and I'll call this file deploy to ec2.sh. so this will be actually a bash script. Next I'll paste the script here for stopping and actually starting a new container. Here I have this instance ID which is the EC2 instance ID, so you need to replace this with your own EC2 instance ID. So I'll go back to the AWS console and this is the instance ID here, so I'll select this instance and then I'll copy this instance ID. I'll replace this instance ID here. This is the container name which should be used by the Docker CLI when creating a new container inside EC2 instance. This is the container image from our GitLab container registry. This is what we have used inside a GitLab CI build stage. When we are pushing a Docker image to the container registry, we are using this CI registry image URL and then we are using the first 8 characters of the commit ID. Next we are doing the same thing. First we are logging into the Docker container registry, then we are actually pulling the Docker image from this app container image which is set to the container registry and the tag name. Then first we are stopping the container by using this script. So if the container is already running, then we do a docker stop. If the container is not running, then we are skipping the container stop command. And once we have all these commands ready, we are actually sending this command to EC2 by using the AWS SSM Agent, and this is using the send command, and we are using the run shell script, and the target is setting the instance ID here, which we have that here. So first it will log into the container registry by using the Docker login. Then it will pull the Docker image which we have just pushed inside the build stage. Once the image is pulled, it will stop the existing container if there is any. Once the container is stopped, then it will run a new container. The container will not be stopped, so in case the container stops for any reason, it will be restarted unless you stop a container manually, which we are doing here. So only this stop command is allowed. Otherwise, if container is stopped for any reason, it will be automatically restarted. And then we are checking the status. If the status is success, failed, timeout or anything, then we are breaking the step. Otherwise we are checking for the command status if the container is ran successfully or not. If anything happens unexpectedly, you will see the output here that the final output either failed or either successful. So now let's commit these changes and we should be good to have a Dockerized Next.js app deployed through GitLab CI to EC2 instance by using SSM Agent and identity provider. I'll go back to the pipelines and I'll click on the pipeline. Currently the build stage is running, so once the Next.js app is dockerized and pushed to the container registry, then it will move to the deploy stage by pulling the Docker image to the EC2 instance and then running a new container. So the build stage is successful and it has pushed the Docker image to the GitLab container registry. If we go back to the deploy stage, now the deploy stage is running. The deploy stage is successful and it has configured all the things we have mentioned by using the SSM manager, then installing the manager plugin, then creating the AWS token for getting access. It has set this role ARN with the web identity token file. Here you can see from the STS that the caller identity this is the user ID, this is the account, and then it's using this assume role, and next it's running the deploy to EC2 script. It's continuously checking that the script is in progress by stopping the container and then running a new container, and once the container is up and working, then it will actually stop checking for the script status and the job is successfully here. Now if we go back to the EC2 instance, so I'll copy this, I'll open a new tab. Here I'll try to get access to the app through this IP, but make sure you are trying with HTTP and not HTTPS. I'll put that IP with HTTP. Here you can see that the app is deployed to EC2 through GitLab CI without managing any manual SSH keys. And if you make any change to this application, and if I go to this repository, go to the app and go to the source app, go to the page.tsx and edit here, and I'll print a message here that GitLab CI is awesome. The moment I commit these changes, the pipeline should be triggered again. It will build the image with these new changes and it will deploy this updated application to EC2 in just a matter of 2 or 3 minutes. So I'll commit these changes. I'll go back to the build and pipelines, and now let's wait for 3 minutes. Once the pipeline is succeeded, we should have this Next.js application updated with whatever text we have added. Pipeline is succeeded. If we switch back to the Next.js application and if we do a reload, you can see here GitLab CI is awesome. So this is how pipeline and automation can help you to build, test and deploy your applications without adding any manual steps. To revise quickly what we have done, that first we set up an EC2 instance, then we install Docker and SSM Agent on that EC2 instance by SSHing into that EC2 instance by using its private PIM key file. Then we created a couple of IAM roles, one for the GitLab identity provider and one for the SSM agent. And once we had that SSM agent role, we attached that role to the EC2 instance, so the EC2 instance can know that okay, I need to give access to the SSM agent based on this role permissions and policies. And once we have everything configured on the AWS side, we created a GitLab CI pipeline where we have a build and a deploy stage, and the deploy stage was actually triggering a deployment script which was actually taking care of the stopping container and running a new container.